Have you ever stopped to think about the hidden genius that's packed inside your phone, or your Wi-Fi router, or even your car's radio? They're all absolutely full of these tiny components called filters. And you know, the way engineers design them, it's just a masterclass in elegant problem solving. It really all boils down to this incredible idea called the prototype filter.
Well, let's be honest. It's not just engineers, right? Nobody likes doing the same really difficult task over and over and over again. The problem is, pretty much every single piece of electronics needs filters to, separate the signals you want from the noise you don't. But designing a filter from scratch for every single application, that would be an absolute nightmare.
So let's really frame this challenge. We're living in a world that is just flooded with signals. And because of that, we need a nearly infinite variety of filters to manage them all.
Just think about it for a second. A Wi-Fi signal operates on a totally different frequency than an FM radio station. And the circuitry inside your headphones? It has a completely different electrical characteristic, we call it impedance, than, say, the antenna on your car. Each one of these needs a custom-built filter. I mean, if you had to recalculate and redesign everything for every single one of these combinations, well, innovation would just grind to a halt.
So faced with this huge, repetitive challenge, engineers came up with a really brilliant solution. Instead of starting from scratch every single time, they created a master blueprint.
And that blueprint is what we call a prototype filter. The key phrase here, the whole magic of this idea, is universal template. That's the core concept. You design one perfect, totally generic filter, and then you use that as the starting point for everything else.
Honestly, this is the perfect analogy. You wouldn't invent a whole new recipe just because you wanted to make a lemon cake instead of a vanilla one, right? No, you'd start with a perfect base recipe for a cake, and then you'd adapt it. Add some lemon zest, tweak the sugar. The prototype filter, that's the perfect base recipe. So what does this master recipe actually look like? Well, to make it truly universal, it's designed with the simplest, cleanest numbers imaginable.
So the standard prototype is a low-pass filter, which just means it lets low frequencies through. And it's designed with these super simple settings, a corner frequency of 1 radian per second and an impedance of 1 ohm. Now, in the real world, these numbers are totally useless. But that's the point. They are incredibly easy to scale up or down. The big takeaway is this. You start with 1, and from there you can just multiply your way to any number you actually need.
Okay, so how does this actually work? This is where the magic really happens. How do you take that simple little blueprint and turn it into the exact filter you need for, let's say, a 2 megahertz signal that's in a 75 ohm system? It's really a 3-step process. First, you do something called frequency scaling to match the frequency you're aiming for. Second, you do impedance scaling to match your circuit. And honestly, those two are basically just multiplication. But that third step, bandform transformation, that's where things get really, really clever.
This is the one. This is the step that lets you change the fundamental behavior of the filter. We're not just adjusting the numbers anymore, we're changing what the filter actually does.
Okay, so remember, our prototype is a low-pass filter. You can think of it like a bouncer at a club who only lets the low guests in. A high-pass filter does the exact opposite. It only lets the high guests in and blocks all the low ones. So they're total functional opposites.
Now, you'd think this would require a complete redesign, right? A whole new blueprint. But the solution is, it's just breathtakingly simple. How do you flip the entire function of a circuit like that?
And here it is. It's so elegant. You just swap the parts. That's it. You replace every inductor, the components that store energy in a magnetic field, with a capacitor, which stores energy in an electric field. And you do the reverse for the capacitors. With a little bit of math, you've just completely inverted the filter's function. It's absolutely genius.
Okay, so swapping parts works great for turning a low pass into a high pass. But what if you need something more specific, like a band pass filter? This is like a really picky VIP bouncer who only lets in guests in a very specific frequency range. Not too low, not too high, but just right.
To pull this off, the transformation gets a little more advanced. So instead of a simple one-for-one swap, each single component in our prototype kind of blossoms into a pair of components that work together. And these pairs are called resonators. So here's how it works. Every single inductor from our original low-pass prototype, it transforms into an inductor and a capacitor connected in a line, what we call in series. And every capacitor from the prototype, it transforms into a capacitor and an inductor, connected side by side, or in parallel. By doing this, you create a circuit that's perfectly tuned to resonate at, and therefore only pass your exact desired band of frequencies. So cool!
All right, let's zoom out for a minute, because this is way more than just a clever electrical engineering trick. It's really a powerful philosophy for how to solve really complex problems in a super efficient way.
I mean, the benefits are just huge. Engineers can now design incredibly complex filters in a fraction of the time it used to take. The results are super reliable because they all come from one proven, perfected design. And the whole process becomes standardized, which makes it so much easier for everyone to build on each other's work.
This quote really just sums it all up perfectly. The power isn't in the prototype itself, it's in its incredible adaptability. It's that property that you can derive everything from this one starting point that's the real key.
So when you boil it all down, what you're left with is this beautiful design principle. Don't solve 1,000 tiny, unique problems one by one. No. Instead, solve one big, general problem perfectly. And then, create a simple, elegant set of rules that lets you transform that one perfect solution into 1,000 specific ones.
And that kind of leaves us with a really fascinating question to think about. This whole idea of a universal template, it's all over engineering, but where else could we apply it? In software development? Maybe in architecture? Or manufacturing? Where else out there can we find a master recipe just waiting to be adapted?